Hello, and welcome to the Azure Data Explorer webinar on how to start with the Kusto query language. My name is Olga Goldenberg, and I'm a Senior Product Manager here at the Kusto Group, developing the Azure Data Explorer. Slavik, would you like to introduce yourself?
Hi. My name is Slavik Neimer, and I'm a Principal Software Engineer in the same team. Good to be here.
Perfect. So let's start. So as you may have noticed, you are all muted. But feel free to ask any question in the Q&A section, and our wonderful moderators would be happy to help and answer. So by the end of this presentation, you would have a pretty good idea of what is the Kusto query language, how to write a simple data exploration query, and also how to draw basic insights from your data. Your KQL journey starts here, in this webinar, which is part of the ADX webinar series. But there's still a road to become a true KQL ninja, and we're here to support you with lots of relevant materials. So first of all, we have some beautiful online KQL courses for beginners and also for advanced users. We also have quite a few KQL articles in our documentation center that you may find useful as you start using KQL. And then, as you become more proficient, you can find lots of detailed operator description and usage examples. And finally, we have a very live tech community where we post blogs, articles, and all sorts of useful information. So be sure to follow us. But out of all of these links, the most important one for today is this one. So if you haven't done this already, please join me and log into Azure Data Explorer Web UI to have a true hands-on experience. So go to dataexplorer.azure.com/cluster/help to join us. So what is KQL? So as I mentioned several times, KQL stands for the Kusto query language. And it's the main language used to interact with ADX clusters, but it's not the only one, as I'll show you later. KQL is widely used in Azure on platforms such as Azure Monitor with Log Analytics, Application Insights, Sentinel, and Microsoft Defender. So it's a useful tool to add to your tool belt. It's optimized, but more than that. It's purpose-built for big data, diverse, fast-flowing data from application logs, websites, IoT devices, and more. You don't have to prepare your data for exploration when using ADX, so no indices, no primary and foreign keys, just ingest your data and it's ready for exploration. But in my eyes, the main advantage of KQL is how simple it is to use. It has a very low entry barrier. It is easy to read its syntax, and it's simple to author query with the best IntelliSense that guides you step by step. And it truly democratizes data. It's intuitive and it's highly productive. The language consists of hundreds of query operators and functions such as aggregation, filters, and so on. But it also has built-in machine learning and geospatial capabilities. And it's scalable. As you'll see in a minute, it's very simple to go from a simple one-liner to a complex data processing script. So before we move on to how it actually works, I just want to show you something. So come with me and open your Web Explorer. Here we go. So this is the Azure Data Explorer Web UI. And I don't know if you're familiar with that or not, so we do a really short walkthrough. So here on the left, we have the query experience. We also have the dashboard experience. I'm sure you'll have a webinar about dashboards pretty soon, so stay tuned for that. We'll close that for now and focus on the query experience. So for the query experience, we have the query editor, we have the results pane, which will be here, and we have the connection pane. So if you use my link, you should already have the help cluster here. But if not, we'll just add it really quickly. So we'll go to add cluster and type in help and add it. Cool. So the help cluster is a public cluster. It's out there for any Microsoft authenticated user, so you should be able to access it. It's here mainly for educational purposes, and it contains sample data that you can practice on. So it has currently a single database. It's called samples. And here under table, I'll go to the storm events table. So storm events holds environmental data published by the National Environmental Institute of the United States. This is data for the year of 2007. Okay, so for the entire year. So we actually going to start not with KQL, but rather with SQL. So in order to query a Kusto cluster using SQL, we need to write those two dashes, right? Like a comment in SQL, if you're familiar with that. And let's start. So we have this table, we don't know much about it. So we'll start with selecting, let's say, top 10 records, right? From storm events. And we'll order them by, let's say, start time. Okay, so the latest top 10 events from storm events table up. We have a mistake here. And we are ordering them by a start time descending. Let's run that. Now, you can use the run button to run queries, but you can also, as indicated here in the tooltip, can use Shift Enter, and that's what I'm doing. So let's close the left pane and focus on the results. So here we have the results, and now let's write a bit more complicated query. Let's say we want to create a simple filter. So we want to select still top 10. We don't want all the results here. No, sorry. From storm events. And I want to create a simple filter. So where, let's say, state, right, is Alaska. We can see. And I, again, would like to order by, let's say, start time. Cool. So I have the 10 latest events that happened in Alaska. So we have here, as expected, high wind and blizzards and storms and so on. So we have the last 10. Now, let's move on to KQL now. So we have this query. It's a very simple query in SQL, and we'll try to create it with KQL. Now, join me and let's do this. Now join me and let's do this together. So what you need to know about KQL, the first and the most important thing, that every query starts with a tabular input, and then every operator produces a tabular output. Okay, that's how KQL works. So we'll start with the first tabular input, which is actually our table. So every query in KQL always starts with the table. Okay, and now as I'm starting to write it, you see immediately the intelligence kicking in and suggesting me all the relevant table names that I have in this cluster. So I'll just select storm events. Right after I select the storm events, I already have my first pipe sign. All the operators in KQL are always separated by pipe signs. So every pipe sign actually receives a tabular input, then we have the operator, and then at the end of the pipe sign, there's a tabular output produced. So let's start with that. So we're looking for top 10 events from Alaska. Now, first we need to find all the events in Alaska, right? So where? State. Here we go. We have all the columns here. Equals. Now, notice the difference in KQL. we use double equal sign for equals, and we use a single equal sign for placement. Okay, like a variable placement. So where state is Alaska, and then we would like to take the top 10, and we would like to order them by start time. Okay, now I did very, very little typing here. Okay, almost all the things that I needed to type here, except for the free text, were suggested to me by IntelliSense. So that's the cool thing. So we have the query here, and let's run this. And we have, again, the top 10 results automatically by descending from Alaska, and we see the same results that we've seen before. Now, when we look at that, and that's the beauty of KQL, you don't need to be an expert in KQL in order to understand what we're actually trying to say here. So we have the table, and we're looking where state equals something, and we are taking the top 10 results by start time. And it's really simple to understand, it's really simple to read, and it's really cool. So now that we've seen that, let's move back to our presentation and take a look at how it actually works. So as we said before, the magic with SQL is that we always start with a table, and then it produces a table, and then we run another operator on the table, and produces a table, and so on until we get our results, right? Now we can have the language is consisted from query statements, like this is a statement, right? We have a table, we have a bunch of operators separated or sequenced by a pipe sign. And this is a single statement, but the query can also contain multiple statements. We can use the let statement for reuse purposes. In this case, we have created a variable, US state Florida. The variable doesn't have to be a single variable. It can also be an entire table. For example, you can create a lookup table and so on. And then we have multiple query statements actually reusing, look here, reusing our variable that we've created with the let statement. The output of this would be two tables. The first one will show us the count of all the events during November, look from November 1st to December 1st of 2007 that happened in Florida, and the second one would be all the events that had casualties. Okay, so that's quite simple. If we have multiple statements, we would usually separate them with a semicolon, just to know that there are more coming, and that's it. That's the language. Now I will move on to our more serious and heavy demonstration part, led by my colleague Slavik. So Slavik, lead the way.
Okay, so we're going to work with the storm events table, which contains data about storms in the US from 2007. So let's start by looking at its schema, the columns that it has, and the sort of data. So as you can see, we have a record for every storm. We know when it started, when the storm ended, and in which state it happened, and the event type. We scroll a little bit here. We can see how many people were injured directly and indirectly, how many people died, damage in property and damage to crops, and tons of other data. Now, let's see how many records the table has. So using the count operator on line 9, I can see that the table contains about 60K records. Okay. Now, let's see only the records where there was damage to crops. So on line 13, you can see that I have a filter that filters records where the value in the damaged crops column is greater than 0. So as you can see here, we have damaged crops greater than 0 indeed. Now, we can chain multiple conditions, like you see in this example. So I have a condition on line 18 saying that I want the damage property and the sum of damage property and damage crops to be greater than 0. So as you can see, arithmetic operations are allowed, and obviously we can do much more complex stuff, but this is a basic example here. And in the next line, we have another where operator saying that I only want to see records where the value in state column is Florida, and I want the result to be ordered by damage property value in descending order. So that I do with the order by operator, as you can see on line 20. Cool. So let's see here. As you can see, it's indeed Florida everywhere. The sum of damage crops and damage property is indeed greater than 0, and the results are sorted by the damage property in descending order. Cool. Now, let's take a look at the 5 storms that caused the most damage property. We do that by using the top operator, which basically sorts all the records by the damage property in descending order and displays only the first 5 records. So as you can see here, we got 5 records and the damage property is indeed very high here, and it's sorted in descending order. Now we can of course combine the two. So as you can see in this example, on line 28, I have a filter. So because I only want to see event types having the word wind in it. As you can see here, we indeed get events with event type high wind and thunderstorm wind. And we got 5 records sorted in descending order by the damage property value. Cool. Now, when you're using has, it's actually using indexes. So in Kusto, we have automatic indexing for all the columns that you have, and you don't need to choose which index you want for which column, and you don't have to define primary keys and foreign keys or anything of that kind. We just index everything. So when you have a line 28 here, looking for event types that have the word wind in it, we just do it in a very efficient way. So you don't have to worry about anything. Now the interesting thing is that wind should be a separate word here, as you can see in the results. We have high wind and thunderstorm wind, so that's okay. If we want to look for a substring, we have to use the contains operator. And in this case, indexing is not used because we have to really go over each and every record and see what it has in the event type value. So we got the same results, which makes sense in this example. Cool. Now, let's find events that cause damage to property in Florida, specifically in Q1. How do we do that? So I have a filter on line 33 saying that the start time should be between January 1st, 2007 and until March 31st. So that's line 33. Then I also want to filter by 2 other fields, as you can see here, damage property greater than 0 and state is Florida. Now, I don't really want to see all the columns here because we have far too many. So I only want to project the 3 interesting columns that I want to look at: the start type, the event type, and the damage property. So indeed, we got only the 3 columns, and the damage property is indeed greater than 0. Now, we can't see that the state is Florida because I didn't include it in the project query. The project operator, sorry. Okay, so let's go get some insights on the data. Now, by insights, I mean, I don't just want to see the raw records in the table because that's not really interesting in most cases. So sometimes or in most cases, I want to get do some aggregations of the data to get some more meaningful insights. Because normally your tables will have millions or billions or even more records. So let's see the total damage per state, for example. So here you can see that on line 43, I use the extend operator, which basically creates a new column called damage that has the value, which is the sum of damage property and the damage crops. Now, as you might remember, in Kusto, every operator receives as an input a table, and its output is a table as well. So the extend operator basically adds another column to the input that it received and passes it on to the next operator. So on line 44, we have the summarize operator. So what we do here is, what we actually want to do is look at the sum of the values in the damage column by state. And we want to see the top 10 states with most damage. So as you can see here, in California, the damage was $2.8 billion in that year. Wow. So that's more interesting than looking at raw records, right? Now we can do more interesting stuff in the summarize operator. So here's just an example. Here we look at the count of storms by state. As you can see, every summarize operator, we normally end it with a by. So we have by state here on line 54. So for every state, I want to see the count of storms, as you can see on line 50. And I want to see how many of the storms caused damage to crops. So we have the count if function here, which I can use. And as you can see on line 51, I can give a new name to the result. Now on line 52, I want to see the distinct count of event type. So because we have many different event types, I'm curious to see how many different event types of storms we have per state, and also the minimum start time and maximum end time, so that for every state I'll know when the first storm started and when the last storm ended. So as you can see here, we have indeed the count. In Texas, there were the most storms, and 72 of them that caused damage to crops, and there were 27 distinct types. And you can see the mean start time and max end time. Now, that's very interesting. We have 27 different event types only in Texas. I don't think I even know 27 different storm types, right? So let's see the distinct event types that we have in the table. So we have the distinct operator here on line 59, which just returns all the different event types that we have. And on line 60, you can see that I sorted them alphabetically. So we have tons of different storm events here. And yeah. Okay, so let's see which storm occurred most of the times. So on line 64, I summarize by the event type, and I want to see the count for each one. So as you can see here, thunderstorm wind is by far the most, and hail actually, are by far the most frequent storm events, or at least they were the most frequent events in 2007 in the United States. Now, suppose I want to see the amount of thunderstorm wind events week by week. So I filter on line 69 all the events with thunderstorm wind in them, and I summarize by bin start time 7 days. Now, what it actually means is that I want to count the events that happened not just for the whole period, for whole 2007, but I want it with intervals of 7 days. So it actually means that we take all the data and we split it into bins of 7 days, and we see how many storms happened in every bin of 7 days. And we create a column chart. So let's see what it produces. Okay, so interestingly enough, we can see that there are more storms in the summer, thunderstorm winds, sorry, in the summer than in winter. I have no idea why that happens, but that's what the data says. Now, as you can see, the difference between every 2 bars is 7 days. So here it's May 28th, and here it's going to be June 4th, for example. Now, suppose I want to see the same data, but not week by week, but month by month. So what I do here is on line 76, sorry, you can see that I bin by start of month, start time. So what it actually does is it looks at the start time of every storm, and it changes the value to the beginning of that month. And then I bin it into bins of 1 day. It doesn't really mean anything because all the storms are going to be January 1st, February 1st, March 1st, etc. And I render a time chart, column chart. Sorry. So yeah, we can see that in June, July, and August we had the most thunderstorm wind events. Okay, now we can do the same investigation actually with a single query. So using a let statement, I can create create a variable that's evaluated separately, and then I can use it in the main query. So I want to find the most frequent type, as you can see on line 80, and I get it by looking at the storm events data and summarizing by the event type and looking at the first record and projecting only the event type. So this part here will actually return thunderstorm wind, right? That's what we saw before. Now, on line 80, you can see that I used toScalar. What it actually does is it receives a table with 1 record and 1 column, and instead of storing it as a table, it actually stores it just as a scalar, just a variable. So it's going to be called the most frequent event type. What I want to do now is go over the main query. So on line 85, you see that we look at the storm events, where the event type is the most frequent event type, which we calculated before. And then I do the summarize that you saw before. As you can see, it's exactly the same results as we saw before, not surprisingly. So that's pretty useful. Now let's take a look at another example. Suppose we want to get events with the most damage to property and crops. Here you're already familiar with everything. We use an extend operator here, and stop and project. Now, in the extend, I actually create a new column called damage with the sum of damage, property, and crops. And I look at the top 5 records with the highest damage, and I only project some of the columns here. Now, suppose I want to get events with the most damage to property and crops in states where the population is less than 3 million. So, as you can see, I can use a let statement just to put a variable here, 3 million. I don't have to do it. It's just very convenient in case you have a long query, complex query, and you want to put all the constants at the top of the queries, at the beginning of the query. So it's very convenient to just put all the constants as let statements. Also, I want to see which states we're interested in at. So I have another let statement on line 100, where I look at the population data table, which you'll see in a second. So it has, for every state, its population. And I look at all the records where population is less than 3 million. which I have in the previous let statement, and only project the state. So as you can see, I'm going to get here this guy here as well. I can't evaluate it actually. So I can do here small states. So I have Alaska, Delaware, etc. So these are all the states with less than 3 million inhabitants. Okay, so now I want to look at the storm events where the state is one of the small states using the in operator here, as you can see on line 105. And then I do things that you already know. So here I see all the events with most damage to property and crops, only in states with population smaller than 3 million people. Okay. Now, actually, I create a function that gets the states with population smaller than a certain amount. So I do it using the create all alter function, and it's sort of a storage procedure that you can create once and reuse in multiple places or let other people reuse it. It's stored as part of the database, so it's really convenient. So here I create a function that receives one argument, which is the amount, as you can see on line 111. The type of amount is long. And what it actually does is goes over the population data table and it does some filtering and returns only the state. So you saw that before. So let me run it to create this function. And now let's try it out with, say, 1 million here on line 118. So here you see that we have 7 records containing states with less than 1 million people in them. Okay, now we can run the same query as before, but this time we'll use the function that we created before. So as you can see here, on line 122, we use the get states with population smaller than, and we pass the value of 3 million, and we get exactly what we got before. Instead, this time we don't use any let statement because we can just use the function here. Obviously, we could use the let statement. It's not necessary. It's just, it was convenient in the previous example where it was a longer thing. Okay, now let's do a similar thing, but also we want to display the population. So how do you do that? So you're obviously familiar with the join operator, right, in SQL. So in Kusto, we have the join operator as well, and we support multiple types. So here I only show the basic one. So what I do here is I take the population data and I filter only records where the amount of inhabitants is less than 3 million. And I join it with the storm events table. Now I join it on the state value. What it does is actually, it produces a record for every combination of the input for the join operator and the storm events data, where the value in the state column is identical in both. That's because they used kind inner, as you can see on line 130. Okay, so let's run it. As you can see, we got the same results, plus we have the population value here. And as you could guess, since we have the join operator, we have also the union operator. So I can just take, say, population data with less than 1 million people and union it with population data where the amount of people is more than 25 million, and order by population in ascending order. And as you can see here, we have these guys here. So indeed, we only have states with less than 1 million or more than 25 million. Now, of course, I could do it with a simple where operator using the or, right? something like population data, where a population is less than 1 million or population greater than 25 million, and order by population ascending. And I'm going to get exactly the same result as before. It's obviously much easier. I just showed you the previous example only to show how the union operator works. So I hope you enjoyed this demo. It's really basic. You can do much more complicated stuff here. So I just wanted to give you some taste. And this table is actually very small. It's only about 60K records, but Kusto operates on huge tables and performs all the queries really fast because of all the indexing that we have, automatic indexing. So we'll go over that in another webinar, but basically Kusto stores all the data in what we call extents. So it's basically chunks of data with millions of records in each chunk. And for in every extent, we have statistics per column. So for example, we know the minimum and the maximum value for date time columns and for numeric columns. So if you're looking for a value that's smaller than the minimum or larger than the maximum value in a certain column, then we won't scan any of the records in that extent because we know, thanks to the indexing, that it's just not there. Now we have indexes for string operators as well, as I explained before. So I can really go into great depth about that, but that's for another webinar. So I hope you enjoyed this video. Back to you, Olga.
Okay. Thank you, Slavik. This was really great. And thank you for joining us today. I hope you enjoyed this demonstration and that you learned a thing or two. I remind you again, there's much more to learn and you have all the resources here. There are many more operators and functions out there, so I encourage you to try it out. So follow us on social media and on Tech Community. And if you have any questions, we are always here. Thank you, and thank you, Slavik.
It was good to be here. Oh, and guys, don't forget to ask questions on Stack Overflow if you encounter anything you would want to ask or need help with something. See you.
Great, see you. Thank you.